Yeah, very good morning, all of you. In engineering drawing, welcome to the class. In engineering drawing, we have covered already one unit in which the topics what we covered that geometrical constructions, where we discussed about how to prepare a line into number of parts, how to bisect a straight line, how to bisect an angle, how to prepare normal and tangent to a circle, and how to prepare a polygon using general method and semicircle method. Like that, different diagrams we learned in geometrical constructions. These diagrams definitely will be useful in future problems, particularly in solid geometry. And later we covered conic sections, in which we discussed about different conical curves like ellipse, parabola, hyperbola using general or eccentricity method. Rectangular hyperbola we discussed with asymptotes method. So the topic was covered like that. Later we moved to cycloids. In cycloids, we discussed cycloid, epi and hypocycloid, and two special problems also were discussed regarding examination point of view, special case problems. Later we moved to involutes, in which we covered how to draw an involute for circle and different polygons. So these topics were covered in first unit. Next, according to syllabus point of view, we have entered second unit, which is solid geometry. In particularly in this solid geometry, we will discuss in second unit regarding points and lines. So before going to entering into points and lines projections, first of all, we should know about solid geometry. So this is completely theory information. Just listen how things are happening in this solid geometry and what are the things to be learned here. So I have drawn an optics diagram here. Three mainly things to be observed. One is observer, and second one is plane of projection, and third one is object. So three things I have shown here. One is observer. So here this is observer and plane of projection. Here this is plane of projection and object ABCD I have shown. In between plane of projection and observer, I have placed an object ABCD. Here observer is going to see the object through eye rays. Once eye rays are crossed the object, those eye rays are going and meeting the plane, and that will be giving a shadow on the plane. The image which is going to be projected, which is going to be placed on respective plane, is called as projection. So capital ABCD is object which is placed in between observer and plane. The shadow or image of the object is going to be projected on plane. I have given notation small ABCD. That is image which is projected on plane. So the image which is going to be placed on plane is called as projection. So projection means it is an image which is developed by points of projectors. And you have to connect these points in the proper sequence. Then only the projection will be obtained, that image will be obtained. So this is projection. So finally, four things we have to be discussed or observed here. One is observer, and second one is object. So before object we see eye rays. After object, eye rays are turned to projectors. These projectors are going and meet the plane, and finally it will be giving one image. That image is called as projection. That projection is placed on respective plane is called as plane of projection. So these things you have to be observed from this diagram. So next slide, if you see, what is projection? Just now I told you projection is an image. In engineering drawing, mainly two types of projections we observe. One is orthographic projection, and second one is pictorial projection. Orthographic projection and pictorial projection. In orthographic projection, what I have mentioned on this slide, if you see two diagrams I have shown here, orthographic projection means your projectors means projector means eye rays are crossing the object. When projectors are perpendicular to the plane of projection, what I am telling you, please listen carefully. When projectors are perpendicular to the plane of projection, the image or projection which is obtained on the plane is called as orthographic projection. Projectors are perpendicular. Ortho means perpendicular, 90 degrees. Pictorial means when projectors are inclined to the object and finally going to meet the plane in inclined way. That may be more than 90 degrees or less than 90 degrees, but definitely that projector should be inclined to the plane of projection. That projection is called as, that image which is going to be obtained on the plane is called as pictorial projection, in which we see different types of pictorial projections in drawing, like oblique projection, perspective projection, axonometric projection, like the different projections in which we see isometric projection. So different projections we see in pictorial that will be discussed later, that is not in our topic now. So orthographic projection means what we understood that projectors are perpendicular to the plane, that is orthographic. When projectors are inclined to the plane is called as pictorial. So from these two diagrams we understood that. So now we have entered orthographic projection. So solid geometry mainly discusses about orthographic projection. So orthographic projection means what I told you just now. Projectors are perpendicular to the plane of projection. I already told you in the beginning of engineering drawing gives complete description, particularly in case of orthographic projection. Orthographic projection drawing gives complete description regarding the object in case of size and shape. But the main drawback is that if you go through an orthographic projection, observer has to be moved 3 different directions: regular direction, top direction, and side direction. From these three directions, observer has to see the object and he has to identify the shape and size of the object. So then only he will be getting the complete description. So for that, more time will be taking for going these 3 directions to see the object. So in orthographic projection, what I discussed just now, that 3 views finally will be coming. 3 views. Using these 3 views, observer finally will identify the total shape and size of the object. Those 3 views I have mentioned on this slide. What are they? See, vertical plane which gives front view. Vertical plane view called front view. Horizontal plane view called top view. Profile plane view called side view. So these 3 views finally observer will be getting in orthographic projection to understand the clear information regarding the object. So vertical plane view is called as front view. Generally we denote as FV, front view. Horizontal plane view is called as top view, TB. Profile plane view is called as side view, SV. So these 3 views are very, very important, and these 3 are must for understanding the object description in orthographic projection. I will tell you what are these 3 planes in the next diagram. See all of you this diagram. So here 3 planes I have shown on the slide, 3 planes. See here 3 planes. This is vertical plane. Vertical plane. see all of you. Vertical plane. Sorry. So this is vertical plane. And vertical plane means it is straight and regular direction to the observer. The plane which is in regular direction to the observer is called as vertical plane. Generally, for example, you are an observer, you are sitting on the table in the classroom. You are sitting in the classroom table. So to the observer in straight view, he sees board. So board and that wall is called as vertical plane because it is straight to the observer. Vertical plane. Horizontal plane means the plane which is perpendicular to vertical plane and horizontal and parallel to the earth surface is called as horizontal plane. The plane which is parallel to its surface and perpendicular to vertical plane is called as horizontal plane. So this is horizontal plane. What I have mentioned. So this is horizontal plane which is perpendicular to vertical plane and parallel to the earth surface. Horizontal plane. Profile plane means a plane which is perpendicular to both vertical plane and horizontal plane is called as profile plane. Generally called walls in the classroom. Two walls which are beside the board wall. Two walls which located on right hand and left hand side are called profile plane. Profile planes, two planes, right profile plane and left profile plane. So this is here profile plane. So these are three different planes. On respective planes, we see images or projections. Those projections are called views. The view which is available on vertical plane is called as front view. The view which is available on horizontal plane, which is obtained on horizontal plane, is called as top view. This is top view. The view which is obtained on profile plane is called as side view. So this is front view, top view, and side. These are three different views. Understood? I have placed an object in atmosphere which is straight to the observer. This is straight to the observer. See, straight to the observer. Observer is going to see the object. Finally, the projections or shadow of this image of this object on respective planes are like this. So this is image which is projected on vertical plane for this object. The image which is projected on horizontal profile plane like this. Image which is projected on horizontal plane like this. So this image is called as vertical plane image called front view. Horizontal plane image called top view. Profile plane image called side. These are three different views. For obtaining top view, observer has to see top direction. He has to see the object. From the top direction, he has to see the object. Side view, for getting side view, observer has to move towards right hand side and left hand side direction. He has to see the object. Finally, he will be getting view on profile plane called side view. So like this, observer will move to different directions, top, front, and side. Finally, he sees the object. He gets views on plane, respective planes. What I have mentioned on this slide. When I separate only vertical plane and horizontal plane, as shown on this slide, I have taken a diagram, an object which is placed in atmosphere between plane and observer. Observer is seeing the object. Finally, I have taken only two planes, vertical plane and horizontal plane. Vertical plane means straight to the observer. Horizontal plane means which is parallel to the earth surface and perpendicular to the vertical plane. So these object images are projected on respective planes like this. What I have mentioned on the slide, see here. So this is front view image. This is top view image. These two are projected here. But on your drawing sheet, if you want to draw front view and top view directly, front view image is visible to the observer. But when you see the top view case, top view image is not going to see in regular direction because it is perpendicular to vertical plane. If you want to draw top view on on drawing sheet, what generally we do that, we have to rotate top view or horizontal plane through 90 degrees. Here, we have to rotate plane through 90 degrees like this. We have to rotate horizontal plane through 90 degrees. When you rotate, automatically the horizontal plane also will be visible to the observer. Finally, that will be giving look like this, what I have mentioned here. So it gives look like this. So vertical plane, it is straight to the observer. Horizontal plane I have rotated through 90 degrees. When you rotate in 90 degrees, the horizontal plane comes like this, and the image which is placed on horizontal plane is giving this look to the observer. Horizontal plane view and vertical plane view. If you observe carefully, in the limits of vertical plane and horizontal plane, front view and top view will be obtained on the same limits. Same limits. See, these are front view limits. Within the same limits, you have observed the horizontal plane view or top view. Horizontal plane view does not cross these limits. Within the same limits, these are called projectors. On these limits only you obtain or you see top view. So front view, top view. So on your drawing sheet, you have, if you want to prepare front view and top view, this is a procedure to be followed. Horizontal plane has to be rotated through 90 degrees. Then finally you will be getting an image. That image or diagram you have to be prepared on the same limits of front view. Next topic is 4 quadrants. 4 quadrants. See, I have prepared 4 quadrants. First quadrant is 0 to 90 degrees. Second quadrant is 90 to 180 degrees. Third quadrant 180 to 270 degrees. And fourth quadrant is 270 to 360 degrees. 4 quadrants. These are very, very important in case of projection of points and lines, planes, solids case. Here, from these 4 quadrants, we see 4 types of projections. When object is placed in first quadrant, see what I am telling you, object is placed in first quadrant, the projection which is obtained on respective planes is called as first angle projection. When object is placed on first quadrant, the projection which is available on respective planes is called as first angle projection. Similarly, when object is placed in second quadrant, the projection which is available on respective planes is called as second angle projection. When object is placed in third quadrant, the projection is available on respective planes is called as third angle projection. Similarly, when the object is placed in fourth quadrant, the projection is available on respective planes is called as fourth angle projection. Like that, we have 4 different types of projections here. First angle projection, second angle projection, third angle projection, fourth angle projection. Now we'll see what are these projections, how and views would be, and how planes would be in these projections. We'll see now. So I have taken an object. See, all of you, in first angle projection, if you observe, object is placed here. Object is placed here. If you observe carefully, object is in first quadrant in between 0 to 90 degrees, and object position, if you observe, which is located above HP, this is vertical plane straight to the observer. These are vertical planes, these are horizontal planes. straight to the observer. This is a plane which is parallel to the horizontal surface. Parallel to the horizontal surface. This is VP and this one is HP, parallel to the horizontal surface. Object is placed here in first quadrant. The position of object is that above HP. Above HP means above horizontal plane and in front of vertical plane. See, object is placed in front to the vertical plane. So in front of vertical plane, above HP, above horizontal plane is the position of first quadrant. When object is placed here in second quadrant, the position would be above HP and behind VP. So backside of vertical plane, you will be getting object. Object position is here now. Object position is here. So behind VP, above HP. When object is placed here, below HP, behind VP, in third quadrant. When object is placed in fourth quadrant, position of object is that below HP and in front of VP. So these are the things to be noted down for student case. First angle projection means, or first quadrant means, object position is above HP and in front of VP. For second quadrant, behind VP, above HP. For third quadrant, below HP, behind VP. For fourth quadrant, below HP and in front of VP. These are positions. Particularly in exam case, you will be getting problem based on these positions in case of projection of points. So based on these positions, you have to identify where that point would be located. What about that plane? So you have to be identified. Based on the position, you have to be prepared diagram. So please take care of this one. Now I am going to separate each and every projection. First of all, I have moved to first angle projection, which is mentioned on this slide. Please see, all of you. I have taken object ABCD, which is in first quadrant. First quadrant means 0 to 90 degrees. Object is placed in between plane and observer. This is observer. Observer is here. And this is plane. In between, I have placed object position. Observer is going to see the object. If observer sees in straight direction, the image of object ABCD is located here. When observer sees from top direction, the image of ABCD will be getting a straight line. It places on horizontal plane like here. So on vertical plane, you see square or rectangle, the shape of ABCD. When observer sees from top direction, he gets only a line which is mentioned on the horizontal plane. So I already told you, if you want to see horizontal plane view, always you have to rotate horizontal plane through 90 degrees. Then only you will be getting that view. Say the diagram will have to be placed on drawing sheet. That's why I have rotating 90 degrees. I have mentioned here 90 degrees rotation I have taken place. So based on this rotation, the views front view and top view you will be getting like this. So this is diagram to be followed on your drawing sheet. This diagram you have to be placed on your drawing sheet. This is the diagram to be placed on your drawing sheet. So this diagram, XY is reference line. This is VP. You will be getting VP here. And below the reference line, you get HP, horizontal plane. So below the reference line, we see top view. Above the reference line, we see front view in first angle projection. ABCD shadow comes like this, image comes like this. On horizontal plane, you look like a straight line. It comes like this. So front view and top view. These are two different views, and in first angle projection. So only two things you have to observe carefully. In first angle projection, above the reference line, we see front view and vertical plane. Below the reference line, we see horizontal plane and top. Object position is above HP and in front of me. So this is first angle projection. Second angle projection. Next. Object is placed in second quadrant. Object is placed in second quadrant. So I have mentioned here. This is our object placed here. If we observe carefully, plane is placed in between object and observer. Plane is placed. Here we have object and this is observer. Here we have plane. Plane is placed in between object and observer. When observer sees the object, the image of object will be placed here, ABCD. This is front view or vertical plane view. When observer sees from top direction, the image of ABCD comes like a straight line as shown on horizontal plane. I already told you, if you want to see horizontal plane view, you have to rotate 90 degrees through clockwise direction. So direction should not change. In every projection, the direction of rotation should be constant. So again, I have rotated through 90 degrees. When you rotate through 90 degrees like previous projection, horizontal plane is going to mix with vertical plane. So that is a problem what we are facing in second angle projection. So when two planes are merged at one side, vertical plane view and horizontal plane view both will be matched, and designer will feel difficulty to understand which one will be front view, which one will be top view. So very difficult to identify. Sometimes both diagrams will be matched. So dimensions of the front view and top view are very difficult to understand for observer case. That's why for industry point of view, we don't prefer second angle projection. Understood what I am trying to say? In second angle projection, vertical plane and horizontal plane will come on one side above the reference line, and front view and top view both will be matched. So very difficult to understand which one is front view, which one is top view, and sometimes very difficult to identify the dimensions of the object. That's why we don't prefer second angle projection for industries. So both, if I rotate this one through 90 degrees, the horizontal plane will be merged with the vertical plane. On one side, you will be getting front view and top view, what I have mentioned on this slide, in second angle. Next one is that third angle projection. This is completely reverse to the first angle. See, this is third angle. Object is placed in third quadrant, 180 to 270 degrees, 270 degrees in third quadrant. Again here, object is and observer. In between we see plane. This is object and this is observer. And this is plane. The position of object is below HP and behind VP. Position of object is below HP and behind VP. Observer is going to see the object. The shadow of object on respective planes come like this. This is ABCD on vertical plane, and CD is a straight line which is available on horizontal plane. If you want to see horizontal plane view, you have to rotate 90 degrees through clockwise. So finally, when you rotate above the reference line, we have horizontal plane, which is completely reversible first angle. Above the reference line, we see HP. Below the reference line, we see VP on third angle projection. But in case of first angle projection, above reference line, we see vertical plane. Below the reference line, we see horizontal, which is completely reversed to the third angle projection. So in vertical plane, This is front view. For horizontal plane, this is top view. So horizontal plane view or top view is located above the reference line. Front view is located below the reference line based on the position of the object. This is third angle projection. This can be used in our industry because we can separate front view and top view, and we can identify the size and shape of the object in a clear way. So this can be acceptable for industry case. Next one is that fourth angle projection. Fourth angle projection, see, object is placed in fourth quadrant. The position of object is here below HP and in front of VP. Below HP and in front of VP, ABCD object is placed here. Observer is going to see the object. In between plane and observer, we have object. This is plane. And this is observer. And here we have object. In between plane and observer, we have object. Observer is going to see the object, and images are projected like this on vertical plane and horizontal. But if you want to see horizontal plane view, again we have to rotate horizontal plane through 90 degrees. When you rotate, horizontal plane is again going to merge with vertical plane below reference line. So in fourth angle projection, when two planes are going to be matched, front view and top view will be matched. Observer again will feel difficulty to identify the front view diagram and top view diagram and size and dimensions. So very difficult to understand the front view and top view. That's why again for industry point of view, we don't prefer fourth angle projection due to difficulties. So what I have mentioned on this slide, you see below the reference line, vertical plane and horizontal plane will be located. Both are matched, and views also will be matched, top to and front. Very difficult to understand. So these are different projections what we have on four quadrants. First angle, second angle, third angle, and fourth angle projections. So I hope that you understood this concept. Next class, we'll see the projections of different objects. First of all, we start with the points. When point is placed on particularly this in these four quadrants, how projections would be will be discussed in next class. Later, after that points, we go through lines. When line is placed in particular quadrant, how projection would be. How plane is placed in particular quadrant, how projection would be. After plane, we'll go to solids. When solid is placed, how projections would be, we'll see in coming classes. So next class, we'll discuss about projection of points. We will see, we'll put a point in different quadrants. We'll see how projections would be in next class. So thank you for concentration on this class. Thank you.